All right, folks, let's talk about prisms, shall we? Where should we start? Where should we start? Okay, I know where we should start. Let's start by talking about what exactly are we talking about when we are talking about prisms. So, first and foremost, prisms are three-dimensional, right? So they have a length, they have kind of like a width, and they have a height, right? So they've got three dimensions, right? What makes a three-dimensional object a prism is the fact that every prism has two bases that are congruent to each other. Okay, so we've got two bases that are congruent. So in this case, the two bases that I'm about to make a prism out of here are both they're both quadrilaterals, maybe they're rectangles or something like that. And then the other thing about the bases is that they are parallel to each other. Okay, so they're kind of like both like pointed in the same direction, right? They're laying in parallel planes. Okay. So with this, I'm going to try to draw. And drawing prisms is kind of it takes a little bit of a practice, but you know, I connect those two corners, those two corners, those two. Okay. What I've got is now the full thing, the full rectangular prism, where I've got these two bases, which I'll use the uppercase B to represent the bases, and then I've got these other faces kind of along the outside. So there's four, in this case four, lateral faces, and two bases, okay? So altogether, this rectangular prism has six faces. Four of them are lateral faces, meaning they're sort of like in between the two bases. And then the two bases themselves, kind of like the top and the bottom, right? This type of prism right here, the way we name a prism, is based on the shape of the base. So this right here would be a rectangular prism because it's got rectangular bases. But bases come on all different shapes and sizes. So if I wanted to do, say, a triangular prism, I would have to do something like, okay, here's a triangle. I'm going to try to draw another one that's approximately the same size and shape, and then connect the corresponding corners. Boom. I've drawn a pretty decent looking triangular prism where the bases right here and here are these two faces that are congruent and parallel to each other. This particular prism, since it's a triangular prism, would have three lateral faces. It would still have two bases. And yeah, this would be a triangular prism. Okay? All right, so I think, one other thing about these is the height of a prism is always going to be the distance, right? The distance between the two bases. So you gotta be really careful about that when we're talking about the height of the prism. What we mean by that is the distance between the bases. So it's not necessarily like how tall it is, because as you can see here, this prism is kind of sitting on its bottom, right? It's not tilted up, it's not standing straight up and down like this. So the height is the distance between those. Okay, now I think that's everything that we need to know. All right, let's get into some formulas, okay? Where should I put this? I'm gonna erase this stuff here. Okay, let's talk first about surface area. Okay, so surface area is sort of like if you found the area of each individual face on this prism and just added all of those together, right? So the surface area is sort of like the sum of the areas of all the faces. Okay? That's sort of like the most basic definition for what surface area is. Okay? But there's a sort of more specific way of breaking this down that makes it a lot easier to calculate, to find the surface area of this prism. Surface area can be broken down into two different parts, those two parts being lateral area and bases. Okay, so what is the lateral area versus the bases? Well, I think the bases is obvious, right? Two of the faces of the prism are always going to be the bases. Okay, so that we'll kind of put aside and come back to later. The lateral area, right, is all of the area of the faces that are connecting the two bases. Okay, so this is all area of faces connecting the bases. Right? Okay. So when we are finding, right, the surface area of this entire prism, the first thing that we'll do is we'll figure out, okay, well, what is the area of just the lateral faces? Okay? And there's a pretty easy formula that we can use to do that. Once we have that, we'll figure out what are the areas of each of the bases. Again, finding that area depends on what kind of a shape you're dealing with. Once you have those two things, you can add them together and you can get the total surface area. Okay? All right, so last piece of this, okay, let's talk about the shortcut for finding the lateral area of any prism. The lateral area of any prism. You can find that by doing this. Okay, so you can find that by doing lateral area equals pH. Okay? You're probably sitting there wondering, what do you mean? I mean, H probably stands for the height of the prism, which it does. But what does the P stand for? So the P actually stands for perimeter of base. Okay? Meaning if you have the dimensions, you have the lengths of all the sides of the base of a particular prism, you find the perimeter of that base, whatever that number comes out to, you multiply it by the height of the prism, and that will give you the area of all the faces, the lateral faces on that particular prism. It's a pretty nice shortcut, okay? And we're going to do an example here in a minute that goes into how that looks with a particular type of prism, okay? Like I said before, with the bases, you know, if the base is rectangle, then you find the area of the base by doing length times width, okay? If the bases are triangles, you find the area of the base by doing 1/2 base times height, right? So finding the area of the bases just depends on what type of prism that you're dealing with, okay? All right, I think I've said enough about that. The last thing will be the volume, okay? So if we're trying to compute the volume of a prism, well, this is actually way easier than all of this stuff with the area, okay? The volume of a prism is given simply by this, okay? Uppercase B times the height of the prism, okay? Where in this case, uppercase B stands for not just the base, but the area of the base, okay? So the uppercase B is really important. If you ever see a lowercase b, then that is referring to the length of a side. If you see an uppercase B, that is referring to the area of a certain shape, okay? So here's the important formulas. Lateral area equals perimeter of the base times the height. the volume of a prism equals the area of the base times the height. And the total surface area of a prism is equal to the lateral area plus the area of the bases. Okay, so I'm going to leave that there for now. I'm going to pause this video. We're going to come back to class, and I'm going to ask if there's any questions about any of this, and then I'm going to make another video where we do a couple examples. All right, so I will see you then.